Hello everyone. In this video, we will learn to name coordination compounds. Specifically, we will learn to interconvert between the name of a coordination compound and its chemical formula. Let us start with an example. CO, NH3 taken 4, Cl2 inside the square bracket, and 1 Cl outside the square bracket. This is an example in which we have a complex cation and a simple anion. There are certain rules we follow while naming coordination compounds. The first rule is we name the cation before the anion. This rule is very similar to the naming of ionic compounds. In this example, the cation is a complex ion. Now, how do we name a complex cation? The second rule says, when naming the complex ion, we name the ligands before the metal ion. And if we have multiple ligands, we name the ligands in alphabetical order. Okay, in this example, we have two ligands, ammonia and chloride ions. These ligands have special names. For example, ammonia is called as amine with two M's. The chloride ion is called as chloro. A list of most common ligands that we use in this course and their names are listed below in the table. H2O is called aqua, NH3 as we discussed is called amine, CO carbon monoxide is called as carbonyl, NO nitric oxide is called nitrosyl. F- is fluoro, Cl- chloro, Br- is bromo, iodo and OH- is hydroxo, and Cn- is cyano. As we can see, for anionic ligands, we drop the suffix IDE and add O after the root name. That is, fluoride becomes fluoro, chloride becomes chloro, and so on. Okay, now let's go back to the compound. We have two different types of ligands, amine and chloro. There are 4 amines and 2 chloros. Now, how do we convey that we have 4 amines? We use numerical prefixes to indicate the number of ligands of a particular type. Note that prefixes do not affect the alphabetical order of ligand names. Now we are ready to name the ligands. We have 4 amines and 2 chloros. Based on the alphabetical order, we name the amines first, followed by chloros. The prefix for 4 is tetra. Therefore, it is tetraamine and dichloro. We are now done with all the ligands. Next, let us name the metal ion. When naming the metal ion, a Roman numeral is used to indicate the oxidation state of the metal cation. We have already learned how to calculate the oxidation number of a metal cation. Let's assume the oxidation number of metal cation cobalt is X, plus we have 4 ammonias. Each of them have a 0 oxidation state, plus we have 3 chlorines. Each of them have -1 oxidation state. The sum of all these oxidation numbers should add up to 0. If we solve for X, we get X is equals to +3. So now let's name the metal. Cobalt followed by the Roman numeral 3. Now we are finished naming the complex cation. This should be followed by name of the anion, which is chloride. So the complete name of the compound is tetraamine dichloro cobalt 3 chloride. Let us do another example. K4 followed by square bracket FeCN taken 6, end of the square bracket. In this example, we have a simple cation and complex anion. If the complex ion is an anion, we drop the ending of the metal name and add a suffix ATE. Let us see what it means. First, let us find out the oxidation number of central metal ion, that is iron. We have 4 potassiums and each of them have +1 oxidation number. 1 iron, let's assume its oxidation number is X, and we have 6 cyanide ions. Each of them have an oxidation number of -1. The sum of oxidation numbers of all the atoms on the compound should add up to 0. If we solve for X, we get X is equals to +2. That is, iron is in its +2 oxidation number. Now let us name this coordination compound. We name the cation first, followed by the anion. The cation is potassium. Next, let us name the anion. The anion is a complex ion. When we name a complex ion, we name the ligands first and then metal ion. We have 6 cyanide ions, and the name of these ions as ligands are cyano. And we have 6 of them, therefore we use the prefix hexa. So it is hexacyano followed by iron. When we have iron, we use its Latin name, which is ferrous. And since the complex ion is anion, we drop the ending of the metal and add the suffix ate. That is, ferrous becomes ferrate. Next, we use Roman numerals to indicate the oxidation number of iron, which is +2. So the complete name of the compound is potassium hexacyano ferrate 2. Let us do one more example. Square bracket cobalt, En taken twice. En stands for ethylene diamine, followed by Cl2, end of the square bracket, nitrate. First, let us calculate the oxidation number of cobalt. We have 1 cobalt. Let's assume its oxidation number is X, followed by 2 ethylene diamines. Oxidation number of ethylene diamine as a ligand is 0, followed by 2 chlorides. Each one has -1 oxidation number, and we have 1 nitrate which has -1 oxidation number. All of this should add up to 0. If we solve for X, we get X is equals to +3. That is, cobalt is in +3 oxidation number. Now let us name the compound. Cation first, followed by the anion. The cation is a complex ion. Therefore, we name the ligands first, followed by the central metal ion. We have 2 different types of ligands: chlorines, which are called chloro, and ethylene diamine. Based on the alphabetical order, we name chlorines first. And there are 2 chlorines, therefore we call it as dichloro. The next ligand is ethylene diamine. Now this is a special type of ligand. The ligand's name has a prefix di in it. For these kind of ligands that include a numerical prefix in the name, we use different prefixes such as bis, which stands for 2, tris, which stands for 3, and tetrakis, which stands for 4, to indicate their number. We have 2 ethylene diamines, therefore we use the prefix bis and we put the ethylene diamine in parenthesis. We are done with ligands. Next, we name the central metal ion, which is cobalt, followed by its oxidation number 3, and then we name the anion, which is nitrate. So the final name of the compound is dichloro bis ethylene diamine cobalt 3 nitrate. Let us do one more example. In this example, we are given with the name of the compound and we need to write down the formula. The name of the coordination compound is tetraamine bromo chloro platinum 4 chloride. So let us translate this name into formula. First, we have tetraamine. Amine stands for NH3 and we have 4 of them. Followed by bromo, which is Br minus, followed by chloro, which is Cl. The central metal ion is platinum with an oxidation number of +4, followed by chloride, which is Cl minus. So based on the name, it looks like the complex ion here is cation and we have a simple anion. So first, let us put the square bracket, followed by 4 ammonias, 1 bromine, 1 chlorine, and then platinum. So we are done with translating the complex cation into the formula. Next, let us translate the anion into the formula. Chloride is Cl minus. The question is, how many chloride ions are there outside the square bracket? Now that depends on the charge on the complex ion. And we can calculate the overall charge on this cation by adding the oxidation numbers of all the atoms inside this complex ion. We have 1 platinum and its oxidation number is given as +4. We have 4 ammonias. Each of them have oxidation number of 0. We have 1 bromine with -1 and we have 1 chlorine with -1. If you add all these oxidation number, we get +2, which is the overall charge on the complex cation. And to maintain the charge neutrality, we need to have 2 chloride ions. Therefore, the final formula is square brackets Pt NH3 taken 4 Br Cl, the end of square bracket, followed by Cl2. Let us do one last example. To convert the name of the coordination compound into molecular formula, the name is given as hexaamine cobalt 3 tetrachloroferrate 3. First, let us translate this name. Hexaamine means 6 ammonias, followed by cobalt in its +3 oxidation number. Next, tetrachloro, that means 4 chloride ions, followed by ferrate 3, that is iron in its +3 oxidation number. From the name, it looks like we have 2 transition metals, that is 2 complex ions. Both the cation and the anion are complex ions. Let us first write the formula for the complex cation. We have 6 ammonias and cobalt. Next, let us find out the overall charge on this complex cation. The overall charge on complex cation is equal to the sum of oxidation numbers of all the atoms. We have one cobalt and its oxidation number is given as +3, and we have 6 ammonias, all of them are neutral. Therefore, the overall charge on the complex cation is +3. Next, let us write the formula for anion. Tetrachloro means 4 chlorines, and we have iron in its +3 oxidation number. Let us now calculate the overall charge on the anion. We have one iron with +3 oxidation number plus 4 chlorines, each of it has -1 oxidation number. The overall charge is -1. So the complex cation has +3 oxidation number and the complex anion has -1 oxidation number. To maintain the charge neutrality, we need 3 complex anions for every complex cation. Therefore, the overall formula is square bracket CONH3 taken 6, end of the square bracket, and begin another square bracket, FeCl4, end of the square bracket, 3 times. Here are all the rules in a single slide for your convenience.